Yeah, I don't actually have the agenda in front of me, but okay, maybe let's start with the client updates first. Dano is first on the list, so Dano, if you want to go first.
I've been on vacation for 2 weeks, so I haven't gotten much done. I listened to the All Core Devs call. I guess that means we're not canceled. I don't know. I'm getting some tasks finished at Hedera, then I'm going to pivot back into making sure that what we have in the Mega EOF branch on Besu matches what is with EVM1, and working on getting testing and differential testing done. I know there's a lot of things that I haven't updated as the specs have changed because they were kind of floating. But now that we got confidence the spec is mostly done, I think it's worth putting in time.
All right,
So
yeah,
that's
we, we
basically the
should
update.
we should get back to the testing question after the client update. Ayman, you want to go next? Okay, your mic is not working. So you got back to implementing the mega spec, I suppose. Awesome. What's your status? What kind of parts have you implemented? Hopefully you're typing. Oh, nice, most of it. All right, hopefully your mic gonna come back later for the call. Yeah, keep writing if you have any more updates. Otherwise, I'm gonna move on to, okay, you're still updating the test from the previous implementation. Are you using any of the, yeah, I mean, let's get back to the testing discussion after the round. I'm not sure maintainer which team you are with, but you sound like you're maintaining a client. Maintainer.eth. If you're talking, your mic is muted. All right, apparently you won't talk. I know I pronounced your name last call, but I still don't remember what's the proper, is it Scorbaggio? I don't know, sorry for the butchering it.
Yeah, Scorbaggio. Yeah, since the last meeting, I took a look into a old implementation that was done long ago for the Ethereum JS client for EOF, and I've just kind of been digging into that. It's not all the way up to date, but yeah, that's uh, the main thing since last time.
So that's on Ethereum JS, right?
Yes.
So what is this implementation from like 2022 December?
Um, I don't have a specific time, but yeah, it seems like it was completed a while back when it was going to be included in one of the hard forks, but it was delayed, so it just kind of sat around and it needs to be updated.
Yeah, I think the base format shouldn't really have changed too much, but obviously we do have a lot of yeah, a lot of other changes. Yeah, just make sure to look at the mega spec. And yeah, if you have any, yeah, I think we could probably point you to the spec of that era, the December 2022 version, and then you can compare it against the mega spec, and it should help you see what needs to be updated.
Yeah, is that a link will be shared in the chat, or is it just going to be in the same repo, maybe like uh an older commit or something?
So the mega spec is in repo now. Let me give the link. But the December version is in notes. Just a HackMD. I will try to find it in a sec.
Okay, appreciate it.
Okay, while I look for the link, I think we could move on to charts. I know you're not a client, but you're Viper. But if you want to give a short update.
The Viper implementation, no updates. I did submit the VLQ, the variable length spec update though, which we can talk about in a minute if you're ready.
All right, so you made progress on that. I think last time we discussed that you could make like a PR just to see what kind of change to the EIP, just to see what level of changes it would require, right?
Yeah, I I thought for some reason that this meeting was tomorrow, so I procrastinated, but I just submitted it right before the meeting, so it's in I pasted the link in the Discord. I'll paste it here too.
All right, yeah, let's discuss it after the round. Okay, then I'm gonna call up Epsilon, and somebody from Epsilon first just give an update on the implementation, like EVM1 part, and then separately maybe testing, and then finally we can move on to spec discussions. Pavel, Andrei, Radek.
Yeah, so in the implementation, we implemented return data load and almost finished, I think, updating DAPN and SWAPN for the EOF spec. And another thing is we have EVM max instructions on review. So this is on the instructions implementations part, as I understand. And yeah, some things are still in progress, like create instructions and stack validation, new algorithm, and exchange of code still not implemented. Yeah, that's about implementation.
Any updates on the testing aspect, like test generation?
We didn't do anything with this last week. We still have this PR on test repo with tests in field format for that's only for creation, for grade 3, I think. Yeah, we probably can work on generating fillers out of that too, but I should note that these tests are not all of the EOF tests that are needed. These are only for creation, actually. Grade 3 and grade 4, I think. So we will not cover with this all of the tests needed.
I think there were like several discussions to use the new testing format as well from Mario's team. Do we know what is the status of that? Are we still generating the state test format, or are we generating that other format? Are we generating both?
We're generating the old format because new format is just Python code, and it also in the end generates blockchain tests of the old format. So it wouldn't make sense to generate Python code. So we kind of generate the final form currently. And what's the status of the effort to write tests in new format? I'm not sure. Probably no updates.
Regarding the clients, other clients and testing, everybody is still using the state test format, is my assumption. So this approach still is valid. Is everybody using, the same version of the test we have, or how do we, what is the current way of coordinating the testing approach?
Are these the tests in Ethereum /tests /SDEOF or wherever it is?
Yeah, but I think it's in a separate repo now, right? Because it's not upstreamed. Andre?
Okay, yeah.
No, I think it is already merged in the main Ethereum test. And yeah, I think the latest tests are already merged in the main. I think it's developed branch.
Yeah, but I think that it's mostly execution tests that are still working according to current spec. And there are many tests that use creation and they use still create or create 2. So these need to be updated for new creation. So it's a mix of some tests still should be working and some are outdated, I think.
So one test format that I think is missing is the validation format, because we went through a lot of validation format fuzzing about this time last year and had set up a file format, but that wasn't accepted by the Ethereum test team.
It was, what do you mean? There is one, and it's also in merged and developed. There are some number of tests for validation. This is in
It's not the same thing. They're running it through Creator, which is much slower, rather than just running the validation directly and getting the
No.
output. Unless they've changed it since last time I've looked. But what the first pass was just another set of tests where they try and make create fail, which was not the same thing.
Yeah, that was the first approach, but this I posted the link. There is a new format specifically for validation. It doesn't run creation. It's just well, these are JSON tests. Maybe I will link the fillers. So it's just bytecode unexpected error. This is basically the format.
But it's not spitting out the discovered code sections? That's what I liked about the format that Marius put together, or Martin, whoever it was, is you either got a failure or you got the list of the code sections, and maybe we should put in the data section here as well. It would show some more validation about that you parsed it correctly, not that you just detected invalid parsing. And I'm looking at this, and is there any examples that passed? Yeah, it was all true. I think we're missing signal from this new format that we had in the old format.
I don't get what you mean. That has error message at least.
No, the error message is one failure, but there was when passed, we passed in a string that represented all of the code sections we found.
So mostly what Martin did was that the tool that was running it was expected to also, in the case of EOF being valid, he was outputting some details about like the internals. And that was kind of roughly specified what it's supposed to be. So it was mostly, I think it was just context of the sections, I believe, something like that. So like the container was removed and the section were just separated by space, something like this. So this is not I think we can add it. I'm not sure this is like super stable test format that I think all the people who are interested in this are already here. So I think we can modify it. I'm not sure if they are up to date. That's the main issue.
Okay. Yeah, I haven't run these yet. I haven't gone through that.
Did we make any do any tests on the creation transactions?
So, the creation transactions probably not yet, but we might be able to generate them easy, like similar to what we have for grade 3. Probably, not sure. Maybe it's because it's a new kind of transaction. Maybe it needs some special support on the tests. I guess it does, like at least new field for any codes.
Yeah, I suppose it's not a blocker for the client implementations yet. If they mostly first have to be up to date with the spec. But yeah, I mean, if implementations do complete, then it's going to become a blocker. Do we have like any estimation how long it will take to get those tests, like at least the first version of those tests out? Andre, do you have any estimate for creating the transaction tests?
If we come up with some format for these tests, then I guess we can generate them, or at least from those unit tests that we have. Yeah, we can have something in the week or something. Yeah. But also in state test format, or like in this new format derived from state test format.
Awesome. Yeah, I think that I do see that as a tiny risk, us fighting with the testing format and transactions. So it would be nice to at least get, a smoke test running to understand if there are any questions there. All right. Do you have any other comments on testing before we move on to spec discussions?
Yeah, I have. So I think like rather quick summary is that we can follow like the kind of regular kind of, I don't know, pipeline of producing tests, which will end up in this Ethereum/tests kind of scheme. And if we were doing that, it's a bit slow because there's multiple tools you need to have to do it. But I think this works. But this opened up like some opportunities to improve the system, and maybe that's confusing that we talk about different things. But I think we can follow the old path for now, and unless someone has suggestions how to change it.
I have a feeling you won't get any feedback before people start using it, other clients start using it, and then once they do, then there's going to be a lot of complaints if something doesn't work.
Okay, I mean, I think it's fine. We kind of open for like comments, like because there's like multiple levels of issues. Like first one is like the format itself, the JSON that is missing some information. Sometimes it's difficult to debug, and all of that. You're probably familiar with this. So I think there are some options to improve that, but I don't think we'll do much unless someone actually have like specific request, or I don't know. yeah, so I don't want to like prolong this, but that's more or less, I think, overview.
Sounds good. Okay, one more question on testing. Do we expect to upstream everything, or do we expect to have like a separate repo for the time being for these tests? And if we do expect it to be upstreamed, what kind of run trip time do we have for merging the changes? I know some of the old ones took like consider, very long time, but maybe it's different now.
I think we can probably merge them as because for now these tests go into these EIPs folder, which is for some future updates. And they don't care that much, I think, about those tests.
Yeah, obviously merging it upstream is the best option. Hopefully it's going to be merged quickly. All right, before we move to the actual specs, I see there's one more person on the call. If I think it's written in reverse, maybe McAley would be the name. I'm not sure. If you're with a client, do you want to give an update?
I'm not actually. I'm with Blockworks. I hope I'm not intruding. I regularly attend the ACD call on YouTube and was curious about EOF doing a follow-up story. I cover a lot of the Ethereum ACD calls. If that's all right, I was just a fly on the wall.
Yeah, that's fine. This is fully public. It may be a bit dry, conversation-wise, but happy to have you here. All right, let's move on to spec updates and discussions because we only have 30 minutes left. I'm not sure, Pavel or Andre, do you want to give an update regarding spec changes? And then I think we can discuss first maybe the proposal from Charles.
I think the only change was we added return data load into megaspec, and yeah, nothing was changed in terms of design changes, just minor updates.
Sounds good. Charles, you wanna get started? Do you want to maybe briefly present what you did and what you have found?
Yeah, so I basically went through the spec and everywhere there's like an offset or a length, I replaced it with, well, okay, first of all, I decided on the encoding format, and I just picked VLQ because it's big endian and it's fairly easy to understand. There's a signed version and an unsigned version. Basically, the unsigned version is easy to understand, and then the signed version, I should write a reference implementation so it's clear, but you just sign extend it and then encode it like you would in unsigned integer. The only weird thing about the sign thing is that you sign extend to a multiple of 7 bits instead of a multiple of 8 bits like you're used to. Should I share my screen or something? That might be easiest.
Yeah, that sounds good. So this is lab 128, right? That's the encoding.
No, I use VLQ. The difference is big versus little endian.
Yeah, I think like going like what specific encoding we want, it's probably like too much of bike shedding at this point. But yeah, I think that the quick summary is like lab 1 to 8, just like the variant of that. So it's kind of similar complexity. What I've read
Yeah.
like before the call. So let's see like variant of this. I would think it's like good starting point.
Yeah. I'm not.
Did we lose audio?
It cut out, yes.
Hello?
Welcome back.
Thanks. I guess it does that when you screen share it. Switches to the audio of the tab. But anyways, where did I cut out? I think I was saying I'm not too concerned about the specific encoding, but like it's should be something that people expect, and it should have this property that it's small for common cases, where the value is small, and yeah, I think variable length, so it just kind of scales with the size of the input is good. Anyways, so we can go through
I think your samples for 127 and 128 are wrong on the signed VLQs.
Yeah, I think I left a note to double check it.
It should be 127 should be 87F and 128 should be 8100. The positive values.
Yeah, that sounds right.
Because you might have a 80 in the case where the low bit is a positive sign indicator. And that's the only case you can do an 80 in.
I think what I want to do is actually implement it, and then that'll be the implement a reference implementation, and that'll be, I guess, the final say. But anyways, so you can see here, like a lot of stuff is just simplified because we don't actually need to like decide beforehand how big things can be. We just say it's like VLQ. Oh, one thing is I decided to add a size bound because I think most implementations want to use a native word to store these things when they actually not during encoding, but during actual running of the thing. And it's easier if things are fit in a pointer. Okay. So I just replaced a lot of these with the maximum is variable. There's some interesting things here where I actually should change this to variable because the 1023 bound is actually checked during code validation. Actually, let me push my changes that I just had.
I do have one comment. It actually didn't occur to me that we were planning to use the encoding also in the instructions. I thought we were mostly concerned by the headers.
Yeah.
But yeah.
I ended up just putting them in the instructions, and it turned out that everything works quite well. But let me finish here first. The only weird thing is that we use OX80 for the non-returning functions. I think, oh fuck, that's a mistake. And I think that was proposed by Andre, and it's a little inconsistent with everything else. So I would suggest that to indicate a non-returning function, you set outputs equal to the max stack height plus 1. And that's the new Sentinel. And I can update the code validation rules. I also took the liberty of, yeah, as Alex pointed out, it's a liberty of changing all the offsets in all the immediates for the instructions to be variable length too. And I think this actually solves a lot of problems because we don't need to decide how big things need to be. So, for example, I remember there was like some kerfuffle about rjump v, like how many bytes do you need to encode the immediate? Where did this go? There. And like this guy. And like now you just don't need to have a limit on how many things can be in the jump table. And a lot of
So-
things improve in the same way.
For our jump, I don't like what variable links do to the implementation. When it's fixed linked, it's a lot of assumptions you can make about code location, about where jump 5 is going to be. It's a very simple math. Now you have to parse and read the entire table, which goes on to my second critique of this, which is it's going to make verticalization harder in some cases, because again, if you get an R jump into a large table that goes across multiple chunks, you can skip those chunks. But in this case, you have to parse the entire table. So when I went through my analysis, R jump is where I decided that variable link might actually reduce utility of some of the instructions that we have. That the fixed length actually serves a very valuable performance purpose in our jump V.
That's interesting. Yeah, we can revisit R jump V. I think that for R jump and R jump I, they should be variable length. Because that makes it easier to lift some code size restrictions in the future. Yeah, and same here with call F, it opens up the number of possible code sections. In the header, I think we can actually remove the terminator because we know, I actually was confused why there is still the terminator field, because we already know the number of code and data and container sections.
So I view that as being forward compatible if we add new type fields. This is a signal to say we're done with type fields. So if an old system tries to read a new version with new type fields, and they see like type 5 before they see the terminator, they know they can't validate it. So I've always, the terminator is the signal that we're done. That makes it clear that we haven't added unknown types, and it preserves forward compatibility.
So with the terminator in place, you can still implement this as a simple loop, like reading the header.
Yeah.
It's probably not what most implementations going to do because we have a kind of fixed header, but technically it still makes it possible.
I mean, I don't really understand the forward compatibility because like what's going to happen is you run into a type kind that you don't know how to validate, and then you need to bail out anyways.
How would you distinguish that type kind from the body section? What if the body section starts with a 5 or an 8, and we have a kind data that's 8? How do we distinguish a kind type header from legitimate data of the next section?
Because all sections start with the kind.
Right, but we're adding in a future version a new kind that just happens to be whatever the first valid input number of your body might be. How do we distinguish those? The way we distinguish it is we have a 0 kind, which says we're done with the header, and then you move on to parsing the body.
Yeah. Okay. I guess that answers my question. Yeah. So I think it becomes like a little bit important for these to be variable length if we want to increase code sizes in the future. And by the way, I noticed that data load n is cheaper than push n, which makes it preferable for compilers to use push n.
Yeah, I think it
use getting n.
would be nice to fix that, but I think we restricted ourselves from changing GATS codes of existing instructions. Just to limit like the number of changes. I don't think there's no reason in current EVM to push have value 3 so much.
So even if it
conceptually-
was more expensive, I would see compilers using data load n for duplicate values across multiple places anyway. Let's say you're pushing the same constant in 15 places.
It's like generally better to use data load n, except for like maybe small values. Like push 0 and push 1, basically. By the way, with the excuse me, with the variable length immediates, we can actually refactor swap in and exchange, which was like kind of contentious for a long time. And the main difference is that is the encoding of the nibbles. So I haven't completely thought through it yet, but if we can use maybe Dano's encoding and take we can do something like the immediate always has to have, we just divide the number of bits by 2, and then the lower bits are considered the low the first stack item, and yeah, there's some way of encoding it, but the low bits encode one stack item, and then the other bits encode the other stack item, and then Solidity and Viper all get to have good properties.
Doesn't the variable length encoding kind of conflicts with this, the two nibble encoding? Because basically what this means that M always going to be restricted to the low nibble, and N, or the top, it's N. N can grow to whatever. So
yeah, I think that swap and exchange should be refactored now.
Refactored into what exactly?
A single instruction which takes a variable length immediate, and then I think the low bit, sorry, the let's see.
I think for simplicity of understanding, we just merge swap in and exchange into one that takes two VLQ values, and then you can go wherever you want. It makes swap 3 bytes, but the only reason we were packing into exchange is because we wanted 1 and 2 byte variants, because we didn't have variable lengths. I'm concerned that if we get too tricky, I mean, if we do it, we should have swap n have 2 values and have one be the first and the second be the delta, and exchange be limited to a single byte that is not variable length and use the old encoding if you're trying to save space. But I don't know how much that really saves us.
I think that having a 2-byte swap instruction is important for code size.
Right. Oh, for code size? Then let's make swap n a 3 byte where it's n and m, and you swap n and the n plus m values, and keep exchange, not make it VLQ, keep the current single byte encoding on it, and not even mess with the VLQ stuff.
I think that you should be able to encode a swap in a single byte, basically.
That would be, well, opcode and immediate operand. You want the swap encoded in a single immediate operand, right?
Yes.
So we keep the current setup for exchange, make it a U8 immediate for exchange, and that gets us up to 16 and 32. And anything beyond that, we use swap n, which is actually has 2 arguments, n and n plus 1. And not n and n plus 1, but n and m, and you swap n and m is the n plus m. If you need more than 1 byte, then you just encode them as VLQ values. So if you're swapping 123 and 124, yeah, it's going to be 4 bytes. But I think that, at that point, you're not really worried about code size. I think it adds too much complexity to move exchange to VLQ.
I think there should just basically be 1 instruction, and it takes 1 VLQ immediate, and then we can be a little bit clever about the encoding, but not necessarily too clever.
I think it's too clever.
Let me write it up, but I think there's an opportunity here to simplify things. And then everything else. What other changes did I make? This was just a clerical. It's just a clarification because they can have other operands besides the immediates. I changed a bunch of things which refer to operands, and I changed them to immediates so they're not confused with stack operands. Push note. Yeah, I think that's about it.
I think those like smaller like fixes we probably could just cherry pick and merge anyway. Yeah, but otherwise, I think this is great work. I do have a number of questions. First of all, did you had any chance to implement both versions in Viper and see, any kind of size differences?
No.
And do you have the current version, the fixed size version implemented?
We have the version from 2022 implemented.
So that means exchange isn't implemented yet?
I don't think so. Yeah, we didn't implement dupe-in and swap-in either.
I think it would be really great to really have some data helping our decisions, right? Between the encoding of swap-in versus exchange, and then also the fixed size versus the variable length.
So
I
I did
think-
some of this analysis on Solidity's output, and what I used to get my, I think, 3% number
But
is I took their compiler.
The 2022 version, right?
Yeah, the 2022 version.
Yeah.
So I took the compiled output and I searched for the prefixes of all of the 2-byte operands, and I looked for ones that were like 00 and between 0 and 127. I looked for all the operands that were below 127, and I considered those to be reducible by 1 byte, and there was about 3% of those occurred. So I think the analysis could be done on the 2022 code with some clever grepping. Not for RJumpV, but
Yeah,
I think we're looking at probably about 3 to 5% by adopting VLQ, but we could get hard numbers.
That's
You mean like-
interesting.
Another benefit is it allows us to like not set hard bounds on a lot of these things. Like I noticed a lot of these things were like, I don't know, arbitrarily chosen as 1 or 2 bytes.
Yeah, I think some of the bounds do make sense, others don't. Even if we make it variable length, I would probably be in favor of having upper bounds on, some of the header stuff, so that implementations, I want to avoid the case of like, what RLP and all these implementations have, that and you basically made the decision already by hard coding what the VLQ upper bound is. But,
Yeah, I toyed around with like using VLQN in the spec, so like VLQ64 versus VLQ32, where the difference is just basically the bound, so it allows the implementation to have some kind of bounds or types. But it seemed to make the implementation, the spec more complicated without gain, but I could revisit that. Like a lot of these things could be like VLQ32, no problem.
right.
So, yeah, and I think VLQ16 should be some of them. And the advantage there, it's not complication, it's about security. Because I could totally see a security attack where they create 4 gigabytes, where they create 4 billion code sections to try and blow stuff up. And maybe more than 32,000 code sections and 33,000 code sections to catch implementations that use a 2-bit number for their indexes instead of a 4. There's various places they could attack this, which is why I think the limits are not about ease of implementation. The limits are not about complexity. They're about security. And if we keep them low, we could always raise them later in a soft fork where we just accept larger numbers. So I think, putting them low on the first pass is not a death sentence to future size increases. We can easily increase them. We can have newer versions. accept larger numbers.
Daniel, the measurement you did with the 3%, was that the instructions only, or was it the header as well, or both?
It was instructions. I didn't mess with the header.
Okay, yeah, I think it would be nice to have two separate pieces of data, right? What is the saving we could achieve with the header and versus the instructions? And I'm kind of leaning towards that probably these are separate questions. From like a spec uniformity perspective, it does look nice that all of it is variable length, but I'm not fully sold yet, that the instructions, I see a bigger risk with the instructions having variable length encoding. Although we already have the argv as variable length encoding, in a different way. But this basically means that every single instruction, EOF instruction with immediates would be variable length. Whether that has implications or not, I think that's yet to be seen. But I would probably prefer to have different data set of arguing whether the header should be variable length and have the data supporting that versus doing the same analysis on the instructions. But I mean, that's my view. We only have like 5 minutes in the allotted time. Maybe we should have some rounds of feedback regarding all of the spec here. What is the feeling we have regarding variable length encoding in headers versus in instructions? Yeah, anybody has strong opinions, please speak up now.
I think one possible downside is it'll decrease the speed of code verification. Whereas for immediates right now, you just get the immediate opcode and you skip ahead to. Now you have to read each byte and do a bit check on the high bit for each byte before you continue. So that's going to slow down code verification. I don't know how much of a big deal that is, but that is one side effect that I see just looking at this immediately.
There's prefix VLQ, which has fewer branches if there's a performance hotspot.
But we still have to read the byte and do some bit twiddling.
Yeah.
Yeah, I like the in this header context. I think I like this because it's allow us to expand the sizes with future compatibility in this sense. Yeah, also I'm not so worried about the verification time, but the instruction decoding at runtime, which from our experience with WebAssembly, which uses kind of similar encoding of numbers. It's if you have a bounded size, it's not a loop, but it's still relatively complicated.
Yeah, I mean,
so I know even implementing push efficiently in current EVM is a bit of hurdle because you need to swap the bytes and all of this. So you can notice this overhead. And I think it's not so bad. I think we can work with this, but it's something to consider. So I'm not sure this is I would prefer to uniformly select this for instructions or not, but seems it's not so easy to do. Especially this jump V instruction, it's really problematic if you do it with periodic encoding. Because now you have to build the table every time you visit this instruction. I mean, I still assume that we're going to implement, at least try to implement EVM interpreter in the way that it just processes instructions without any pre-processing. Because I think we should use it in more, most of the cases. I don't think we aimed to some pre-processing as a kind of recommended step for EVM implementation. So I kind of consider that we will just execute instructions are they are already in the container without doing any modification. So that means you have to decode these values every time you execute the instruction. So
I was kind of assuming that the standard strategy for implementing EOF will be to like cache analysis, but maybe that was a little bit aggressive on that part.
yeah, I think so. We kind of eliminated the need for analysis from legacy. So this the question if you want to add some kind of different kind of analysis or preprocessing instead, because we fixed kind of the issues with the legacy EVM.
Yeah, I mean it's not difficult.
It's not impossible to. It's not difficult. I mean,
it's not difficult execution, and if you, I think it's fairly easy to optimize. But yeah, I see your point.
Yeah, we would need a prototype, but I think it's not difficult to pre-process even during the validation, you can pre-process the code in the form that is like easier to execute by expanding it a bit. And then there's but then you need to store both versions, because one is needed for like verification or like for network, like to prove that this is the code that was deployed. You need it at some point, so you need to store like the old version and the new one as well.
Yeah, I mean this kind of applies to the header too. Although I guess the header isn't really used during runtime. But
some pieces are currently. We try to eliminate the need for this, but I think it's not really progressing to this direction yet.
Can there just be a length thing in the header instead of the terminator? So you just say what the length of the header is.
But we need to parse it to get code data sections so that, that optimization only gets us so far.
Code data sections.
We need to know where they start.
During runtime or during validation?
Yeah, during runtime, you do a call F on code section 5. I need to know what index that starts at. So we need to parse the header or cache the processing.
So I think that you need to decode these things at runtime anyways. And I think that if you want, you can just keep a table of decoded VLQ things. And it is kind of uniform across the header and the code.
One option was to put the call section info as the first 4 bytes of the inputs and outputs, and have call left point to an array index rather than a table lookup. So you jump F to the PC, not PC, it wouldn't be PC, but you jump F to the index within the container. And if the container's been validated, that's where it legitimately starts.
Yeah. That has a code size implication, right? Like it's likely that it's going to be a 2-byte pointer instead of a 1-byte pointer.
Right. But it depends on how frequently you do call Fs. It's not going to be nearly as much as jumps.
Yeah. I think there's a similar issue for data load, and although there's only one data section, so you only need to like figure out where it is one time. I mean, yeah, my current feeling is that it's okay even to do it at runtime. Like decoding a VLQ is like mostly going to just be 1 or 2 branches. And like the PCs are all like normal.
So the other impact is vertical tree encoding, because with that we would have to bring the entire header every time we do a a parse of it. And there are probably strategies we could do where we could put a length on the header and not have to parse the header at all for chunked execution.
Yeah, let's talk about Verkle a little bit because I want to understand how to
Oh,
solve
we're 3
this.
minutes over time. I'm late for a meeting. I need to go.
Yeah. Okay, I'll ping you, Dano.
If
Yeah,
if it's a quick question about Verkle, you can start, but otherwise I think you might want to go offline with this.
Yeah. I think the data for the header is like fairly simple. Actually, I think most of the time you can save basically 1 byte per section. Is that right? And then there's some like constant overhead that you save, or relatively constant overhead you can save in the header.
Yeah, I think in general it's a good starting point. I think some of us might need some time to read it carefully, and I think it's okay to comment on the pull request about details over next 2 weeks.
Yeah.
Charles, do you see any possibility to implement the megaspec in the Viper in the next 2 weeks to some extent, especially the exchange part?
I don't think I'll have time to do that. But what is your concern about exchange?
Oh, it's not concern. It's just it would be nice to have actual supporting data, in the decisions for both exchange and swap in.
Yeah, I think that the design around exchange and swap in were kind of decided because we just, or the amount of the number of immediates wanted was restricted. But I think that with variable length encoding of the immediates, the design space opens up a lot.
Yeah, I think my ask would be more generic, just implementing any version of swap in Viper. And then, because if we have like a base implementation in Viper, then we could try out any of these different options and see, how it fares. But do you think just implementing swap in, exchange, would that be possible within the next 2 weeks without the rest of EOF?
I think it's kind of complicated because it touches the stack scheduler, which is like, yeah, I can put together a prototype, but it's not going to be really accurate. It's just a little bit kind of indicative, if you understand.
Could we use it to compile like Yearn and any of the bigger projects at least?
Yeah, I'll also have to check out like the 2022 fork of Viper probably. Actually, let me see what I can do. I'll let you know.
Awesome. Yeah, I think that would be really, really good input,
Yeah.
to the decision process.
Yeah, with the disclaimer, it's like a prototype.
Yeah, everything is until it becomes production code.
Okay. All right. Thanks, everybody.
All right. Thank you, everyone. Sorry for going over, but it was an interesting discussion. All right. I think we are following the regular schedule, so we have the next call in 2 weeks. And as always, we can keep discussing on Discord until then.
Oh, the EOF repository. I was thinking it can be renamed to EOF specs.
Yeah, I think we even discussed that but probably we had some tools there. I'm not sure. Yeah, we can take it offline. I personally don't have any reason against or for renaming it. All right, any other closing thoughts?
That's all from me.
All right, thank you, everyone. It was great. See you in 2 weeks.
Thanks, everyone. Bye.
Bye-bye.